Good morning, everyone. Thank you for joining us at this very early hour in this mathematics webinar. I am just going to allow a few more minutes for attendees to still sign up. I see that they are still coming in. So let's just give them all a chance. I will allow for 2 or so minutes. Right, welcome everyone this morning to the mathematics webinar. Before we start, I just want to do a bit of an introduction. Right, my name is Linky Young and I am the Chief Education Specialist at Impact for Mathematics and Sciences. Before we start, I just want to make sure that everyone can hear me clearly. I'm just going to highlight that for the guys that won't be able to hear me. So if you're struggling to hear me, please make sure that your audio is turned on and that your speaker's volume is turned up. Right. Let me quickly see. Can everyone hear me? You will see that there's a little hand there on your dashboard. Just put up your hands. Yes. Welcome, everyone. There's still a few hands missing. I just want to make sure that everyone can hear me nice and clearly. There's still a few hands missing. All right, I think that most of you can hear me nice and clearly. When you join into the session, you will see that you are muted automatically. I will unmute you when I want you to ask a question. Unfortunately, we can't open up the microphones at this stage. There's too many learners on this webinar, and it will become a chatting session, and we won't be able to hear everyone. So when I unmute you, you will be able to ask a question. Otherwise, you will stay muted. When you have a question, you can ask your question in the question box on the dashboard that you have over there. At the end of the session, I will make some time to answer your questions. If I see something over there that I can answer immediately, I will interrupt the session and do that for now. We are quite a big group of people here together, so I don't think that I will be able to listen to your questions very much. But like I said, if there's something in between that I would like you to ask and I see that you have something valid, I will allow you to speak up. Right. To raise your hand, we have done that just now. There's an icon on your dashboard in the shape of a hand that you can put up. Do you want to try that again? I've taken down all your hands. You can put up your hands again to make sure that you know where that button is. Thank you. Thank you. It seems like everyone has found the button. Okay, you will find this presentation on your right-hand side in the handout box. You can download that during the session, or you can download it at the end of the session, but when we stop the broadcast, it won't be available for download anymore. So please make sure that you do download that now or during the course of this webinar. It will also be uploaded to our guided learning program platform if you have some access to that as well. So I will remind you again, but you can download that now as well. Right. You will also find all of this information in the question box below or on your right. And remember that you can ask questions in the question box. You're welcome to type your questions over there. I will have a look at it at the end of the session, see how much time we have, and then answer some of those questions over there. Right. Seems like I have a bit of a technical difficulty over here. There we go. Right. Okay, I thought it well to start with the second term's topics. Now, this is applicable for all learners, even if you are registered at Impact or not. So this is what you will do in this term at your school or at home. It all depends on your situation. Right, so the first topic that we will be looking at this term is trigonometry, functions, Euclidean geometry, and yeah, so it seems that you are only going to do 3 small topics. These are quite big topics. These are important topics that count a lot of mark, and we need a good baseline on the work to be done. Right, so I decided to start this term off with trigonometry, and it is good and important for you to have a good base on to base your questions that you're going to answer later on. And you're going to use this trigonometry that we're starting to do today up until grade 12. Trigonometry will be part of paper 2. Now, I want you to remember this and I want you to write it down somewhere or make a knot in your ear or somewhere where you will remember that. Does not mean that you won't see any trigonometry in paper 1. The trigonometry that you will find in paper 1 will be integrated with your algebra. So you won't necessarily use trigonometry skills in paper 1, but they can ask you to use your algebraic skills to answer questions, for example, factorization or simplification or solving for x. All right, but your pure trigonometry questions you can find in paper 2. In trigonometry, you will have to do finding trigonometric ratios from right-angled triangles, finding the side length of a right-angled triangle when you have two sides given. And this should actually remind you a lot of Pythagoras. Trigonometry special angles, solving trigonometric equations, finding an angle in a right-angled triangle, using diagrams to determine numerical values. Trigonometric 2D problems. Right. In all of these, and even when you move a little bit down on this page, you will see that they talk about right-angled triangles. Now, in grade 10, we will only work with right-angled triangles. So there will be no acute triangles, no obtuse triangles, only right-angled triangles. So why do I only speak of triangles? So trigonometry is actually the measurement of triangles. In Afrikaans, we call it driehoeksmeting. It's just measurement of triangles. So trigonometry is based solely on the shape of triangles. Now, like I said, for grade 10, we're specifically only going to use right-angled triangles. And all of you know that we use that little block in the corner where your right angle will be. Right. So let's start with the first topic that we talked about now in trigonometry, and that is with finding trigonometric ratios. Now, firstly, again, we're going to work with triangles and specifically with right-angled triangles. Now, these trigonometric ratios is only applicable to this right-angled triangle, and you will see how we're going to use that. So let's look at the triangle itself as a shape. And we would like to name everything. So you will see this specific triangle has a 90-degree angle, which is your right angle. And then we have two obtuse, two acute angles over there. So acute angles are angles that is smaller than 90 degrees. So for us to write trigonometric ratios, we need to actually name our triangle as well. So we need to give all our sides a specific name. Right. So let's start with the side right across the 90-degree angle over there that I've indicated with the arrow. We call that side my hypotenuse. Now your hypotenuse will always be over your 90-degree angle over there. Right, so I am going to name a specific angle. I'm going to name this angle at the bottom theta. Now you will see why it is important to speak about a specific angle in trigonometry, and we will get to that. But firstly, I want to use an angle to name my triangle. So the side right opposite of the angle that you've chosen, which is not the 90-degree angle, will be your opposite side. Right. When I look at the side right next to the angle, we call that the adjacent side. Right. So you have heard already about the different trigonometric ratios, which is sine, cos, and tan. Now I've written out the whole name over here. Sine, you are used to the blue, sin, cosine, which is cos, and tangent, which is tan. Now, do you see that neither of these trigonometric ratios, sin, cos, and tan, stands alone? I write them in reference of an angle. The angle that I've chosen, we said in this triangle theta. I've chosen theta. Right. Sin, cos, and tan can never, ever stand alone. You should always have a reference to an angle, and in this case, we use the angle theta. Please remember that it will never stand alone. Right. So why do you think this angle is so important, and why it is important to write down my specific angle? I quickly want to show you. So this is the triangle that we just looked at. We called this acute angle theta. We've identified the hypotenuse, the opposite angle, and the adjacent angle. So what about if I chose the other acute angle? My hypotenuse will still be the side right across from the 90 degree. But let's make this top one, let's call it beta. So the line or the side opposite to my beta will be the opposite side. Do you see that this is different now from the theta? The line or the side right next to beta will be my adjacent side. So do you see that it depends on the angle that you choose as your reference? That is why it is so important that you always show where your sin, cos, and tan refers to. Right, so let's use this now. I've just added this triangle over there for you so that it's easy to refer to. Right, before I carry on, let me still see a few hands. Do you still hear me? Are you following me? Are you okay? Thank you. It seems like everyone is still with me. Right. Okay. So this information that we have on this triangle now, we are going to use to find these trigonometric ratios. Now, I've used this word so much, but I'm not sure if you know what a ratio means and what it actually brings forward. Right. So a ratio in mathematics can always be expressed as fractions, as fractions. Right, so if I have a quarter, it means that one part against 4 parts. So a ratio can always be written as a fraction, and that is what we are going to do in trigonometric ratios. So if you look at sin beta can be expressed as the opposite side over the hypotenuse side. Right. Now, this is when I have values. So if the value of the opposite side had a length, let's say 4, and the hypotenuse had a length of 5, I could have given an answer, an expression, a numeric answer to this sin beta. So cos is adjacent over hypotenuse, and tan beta is opposite over adjacent. All right, so let's just recap on that. So sin beta is my opposite side over my hypotenuse side. Sin beta is my adjacent side over my hypotenuse side. And tan beta is my opposite side over the adjacent side. Right, so let's give all of these sides a value. Opposite side I gave 3, adjacent 4, and my hypotenuse 5. Right, so let's get answers for this. So if I look at my sin beta and I want to find opposite over hypotenuse, I'm going to stand at my beta. I'm going to look what is my opposite, which is 3, and my hypotenuse side is 5. So your answer over there will be 3 over 5. If I look at my cos beta adjacent over hypotenuse, which is 4 over 5, and my tan beta is my opposite side, which is 3 over my adjacent side, which is 4. Right. Now, you will see in some textbooks, they also give you this option, and it is absolutely up to you which one of the two you would like to use. You can use this opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent as reference to your angles. Or we can look at axis. So I've drawn there a Cartesian plane, a part of a Cartesian plane with a y and an x axis. And I'm just going to draw a right-angled triangle over there. Now the height of this triangle is actually to reference of my y value. You know, if you think about your functions, your graphs that you have drawn, the height of it is always your y values, and then the x value is over here on the x-axis. And then the hypotenuse that you are used to now is your r, your radius. So why do we call it the r? It's just when I draw a triangle over there with my midpoint at the origin of this graph, which is, or the Cartesian plane, which is 0, 0, and draw it up to the edge or the circumference of the circle, you're actually drawing in your radius. I'm just going to remove that quickly. Okay, so if I take this ratios over here and I translate that into using x and y and r values, I'm still going to use this reference over here, which I've named beta again. So sine beta can be translated into y over r. Cos beta can be translated into x over r. And tan beta can be translated into y over x. So it's your choice. You can use the reference to sides, opposite, hypotenuse, adjacent, or you can make use of the x, y, and r. It's absolutely your choice. I just quickly want to go back to that and just make sure that everyone knows that this will never be given in a formula sheet, not even in grade 12, not as a piece of information somewhere. This is something that you need to study. This is theory. No one is going to give it to you again. You need to go and study this off by heart. Make rhymes for yourself, visualize them, print it out, put it up on a wall. It's absolutely your choice, but you need to make sure that you know this. If you don't know this, you won't be able to do any of your trigonometric questions later on. Right. So let's look at an example of how they can ask this to you. So they say, find the sin of E. Now, if I look at this triangle that they've given me, they've given E, D, and F. Now, I cannot go and stand at D. It's my 90-degree angle. We avoid 90-degree angles in trigonometry like the coronavirus. Okay, so you really do not want to move into that 90-degree angle space. Later on, you will see that bring forth some co-functions and stuff. You see, it sounds like corona, right? So don't use your 90-degree angle as a reference at all. Now, if I stand at my F angle down here, and I use that as reference for sin, you know, I will actually see my opposite side, which is 48, and my adjacent side, which is 55. But that is not what they asked me. They said specifically angle E over there. So I need to go and I need to stand at angle E over there. So I'm standing at angle E. I know that the sin of angle E is opposite over hypotenuse, which is 55 over 73. So there I've just shown you again, make sure that you always stand at the correct angle that the question is asking you to do. Identify your three sides, your hypotenuse, your opposite or adjacent, or it can be your y, x, and r line. And then say, sin E is my opposite over hypotenuse side, so I take my opposite over the hypotenuse, which is 55 over 73. Right, let me quickly see all the hands. Are you still with me? Are you okay? Yes, thank you. This is few still very active. Right, okay. I am going to move on to the next example. So now the question asked me to find the cosine of angle E. Right, so the triangle that they gave me is C, D, and E. I am not going to stand at angle D because they said they want me to stand at angle E as reference. I'm not going to stand at because that is my 90-degree angle and I want to avoid that in all costs. So as far as I can in trigonometry, you will avoid your 90-degree angle over there. So again, I'm going to stand at my E. I'm going to identify my three angles. So if I look at angle E, the side opposite to angle E is my opposite side. The side next to angle E is my adjacent side, and the side right across my 90-degree. Right. Now, sin is adjacent over hypotenuse. So if I look at this, my adjacent side is 12. My hypotenuse side is 37. Right. So this is how you will write your trigonometric ratios. I have put together just a quick list of where you can find some additional practice on writing these trigonometric ratios. So please take the time now this week and work through that. Go and do some extra questions, go and do some extra examples to make sure that you have this, have the understanding that you need to do with this. Right, so I am going to allow now for some questions to be asked. You can type your questions over there. You can also ask your question. Maybe we should see. I'm going to take down all the hands. I'm just going to see someone can put up their hand if they have a specific question to ask me. Wow, okay. All right, I'm going to start at the top. And the first one that I'm going to allow is Diego Sai. I am going to unmute you, all right? And then you are welcome to ask your question. Diego? Okay, seems that he has some problems with sound there or listening a bit of music. I'm just going to move on to the next one. Alaya Hussein, welcome. Do you have any questions?
Yes, ma'am. Is there a difference between the cosine and sine?
Yes. So if you look back on the notes now, you will see that they refer to different sides over there. So the sine is to reference of your opposite to your hypotenuse side, but your cos does not include your opposite side. It only speaks about my adjacent side to the hypotenuse. And why it seems so similar is that they are actually co-functions of each other, the ones that we actually, you know, the 90-degree that we would like to actually avoid at this stage of your trigonometric calculations. But yes, they do refer to different sides, so the answer will not be the same if you calculate them.
Yes, ma'am.
Okay, anything else?
Thank you, ma'am. No, ma'am.
All right. Okay, have a lovely day. Bye-bye. Right, the next one that I will listen to is Liam Mattia. Liam, welcome. Liam, do you have a question? All right, I will be moving on to Suzanne de Beer. Suzanne, welcome.
Hi, sorry.
Hi, Suzanne.
I have a question. I understand for the most part, but the sine, cosine, and tangent, they've never like come up before. Like I understand what they mean, but they're kind of new to me because they never showed up in any of my textbooks before. So
Yes.
that's
So
my question.
trigonometry, trigonometry is a new part that you are actually exposed to in grade 10. So up until grade 9, you didn't really work with trigonometry. So this is really the first year that you will see this in your textbooks. So this will be new to you. That is why I'm starting with the absolute first things that you start with in trigonometry. So this will be new. This will be new. So just, relax about it, just work through the notes and make sure that you understand the basis of all these questions.
Yeah, I've been taking notes so I can make sure that I understand it. It's just like I've never seen sine, cosine, and tangent before, so.
Yeah, it is something new, but it's very nice to work with. It's something that you can visualize because we are working with triangles so much. And enjoy it. You should enjoy that. You will be working with this up until your grade 12 here.
All right, thank you, ma'am.
All right, pleasure. Have a lovely day. Bye-bye. Right, Justin Extian. Justin, can you hear me?
Yes, I can.
Hi, Justin. How are you?
Good, and you?
Good, thank you. How can I help you?
The angles that change when you swap it around, that's all.
Okay, so it is when I change the angle, when I choose another angle as reference. Is that what's confusing you?
Yes, ma'am.
Okay. So it is just to show you that the reference that the question is referring to or what you are writing about is so important. I wanted to show you that when I choose another angle and that it has a huge influence on the answer of the question because it swaps all of the sides around. So what I'm just saying is make sure that you use the angle and stand at the angle. Visualize yourself standing at that angle that the question is referring to. And then from that angle, you identify your different sides. Your hypotenuse, your adjacent, which will be next to you, and your opposite, which will be across you. So it's just to actually alert you to make sure that you use the correct angle as your reference that the question requires.
Thank you, ma'am. Yeah.
All right. Have a lovely day. Bye-bye.
Yeah.
Right. It's a Tankala and Tabisen. Okay, Taba is self-muted. Tandeka is self-muted.
Ma'am?
Yes. Hello.
Okay. Yes, ma'am. This is Takhala.
Hi, how are you?
I'm good, and you, ma'am?
Good, thank you.
Ma'am, I just wanted to ask you to please go back to the first example that you did where we had to find the sin for the angle
All
E.
right. Let's go back. There?
Yes, ma'am, that, yes. I just want to take a screenshot of it so that I can practice by myself when we're done with this session.
No problem. Tanzeka, remember that you can download this whole slideshow in the handout box. So on your what do you call it? On your dashboard, you will see that there is a block that says handouts. This slideshow is in
Yes,
that
ma'am.
handout box. So you can download that over there.
All right. Thank you, ma'am.
Okay, pleasure. Bye-bye. Right, and then I have, okay, she is self-muted. Right. It seems like I don't have any more hands up. Let me just scroll down. Right. So I think I've answered everyone's question. I'm just going to take down all the hands. If you still have a question, now is your time to quickly put it up. Let me see. Yeah, okay. Right. Let's start here at the top at Muluanto. Maluantua. Hello.
I wanted to ask. Hello,
Ah,
hello,
yes.
hello. Ma'am, I wanted to ask about the names of beta and peta. Are these names specifically for trigonometry? Where do they come from, or do we always have to use these names?
Okay. So this is not only for use in trigonometry, it's actually just a variable that I've chosen. These are the typical variables that you will see in your angles. It is not prescribed. They like to use alpha as well, which looks almost like an infinity sign. It's just not closed on the one side. But yes, so this is really just variables that they use. You can, when you do that, name your angles anything. You can name it T, you can name it X. It's absolutely your choice. The alpha and the beta, why I've used that is just because it's common uses as angles that they use to name angles.
Okay. Thank you, ma'am.
All right. It's a pleasure. Have a lovely day. Bye. Right. Chevron Engelbrecht.
Hi.
Siobhan, sorry. Hi, Siobhan.
Hi. I'm struggling to find trigonometry in my math literacy book, handbook.
Okay. All right. So you won't find trigonometry in your mathematical literacy book. Trigonometry is not part of mathematical literacy. This session was only for mathematics. The mathematical literacy sessions will be next week. You will have received, yesterday you would have received an invitation to all of the sessions that we have in the next 2 weeks. And mathematical literacy is only presented next week. On the day before, you will also find an invite or a notification on the Facebook page. So you can also use that as reference.
Okay, thank you. This was a very nice
My
lesson.
pleasure.
Thank you.
Thanks. Bye. Right. Petroline Leroux.
Hello, ma'am.
Hi.
I just wanted to ask if we will be using Pythagoras to determine the sides so we can do sin, cos, and tan.
Yes, so that's definitely the next step in your trigonometric ratios and completion of a triangle in a 90-degree triangle. So this will be so next week you won't have a mathematics webinar, only notes. So that will then build up on this that we have done today, and that will definitely include using Pythagoras to solve sides.
Okay, thank you, ma'am.
All right, pleasure. Have a lovely day. Bye. Right, Joshua Roman. Joshua? Joshua? Yeah, right. Sizwe Jafta.
Yeah, ma'am, it's Jafta, ma'am.
Sorry, I apologize. Sizwe Jafta.
Yes.
How can I
Thank you,
help you
ma'am.
this morning?
Ma'am, I just wanted to ask if like this is like similar to Pythagoras or is it something different?
So it is something different. You will see in the notes that will be sent out next week, which will actually build on this presentation or the webinar. You are going to use Pythagoras, which is similar, is that both of them only works or in 90-degree triangles, right? So I'm sure
Yes.
that is why it actually pushed you to think about Pythagoras.
Yes,
Okay,
ma'am.
so both of them are in 90-degree triangles. Both of them do work with sides. You will actually use Pythagoras to actually get some of the unknown sides in your triangle before you can find the trigonometric ratios. So it's actually, Pythagoras is a tool to this trigonometric ratios.
Oh, okay, okay.
Okay. All right, Sizwe.
Thank you.
Have a
Thank you,
lovely
ma'am.
day. Thank you. Bye. Right. Is it Thalia? Thalia Guru.
Hi, ma'am.
Hi.
How are you?
Good, and you?
I'm good, thanks. Now because of the stuff going on with COVID-19 and things, now the exams changed and stuff, and when we're supposed to do work, will the impact sites also be changing as to when we should start things?
Yeah. So before the lockdown was actually implemented, we already decided that the June examination will start a little bit later. Well, now we don't know really what's going to happen, but you will find all information and everything will be sent to you when decisions was made. We will definitely not let you start the term off with the June examination. We will definitely give you some time. I know that there is also mentions, this is only mentions, nothing is set in stone yet from the department that the June examination will fall away. So you will have classes or your terms will be throughout. But yes, so you will find all of this information when decisions was made.
Okay, thank you, ma'am.
It's a pleasure. Have a lovely day. Bye. Right, I have Comfort over here. Comfort is self-muted. I'm going to move on. Junaid. Junaid.
Hello.
Hi.
Hello.
Oh, it's Comfort. Hi, Comfort.
Hey, ma'am.
How are you?
I'm good and you. I actually have a question about the trigonometry in my textbook. I see that there are a lot of exercises and less information, and I was asking if you're going to point out to some of the stuff you've been teaching us here in the textbooks and the video exercises.
Do you want me to link the exercises to what we have done here?
Yes, ma'am.
Okay. Can I please ask you to send an email to academics@impact.co.za? And then
Yes,
I
ma'am.
can do that for you.
Yes, ma'am. Thank you, ma'am.
Okay, pleasure. Have a lovely day. Bye-bye. Right, I'm going to try again. Jeanette. Jeanette is also self-muted. Right, let me just see the time quickly. We still have a little bit of time left. There's also someone self-muted. Just want to put Opsie's way over here. Right, Antoine de Waal. Anthony, you are self-muted, so if you want to ask a question, please unmute your microphone.
Hi, ma'am.
Yes. Hi.
My question that I wanted to ask you was already answered by you. Thank you.
Okay, great, Anthony, thanks, bye. Right, guys, I'm gonna take down all the hands again. If you have a question that was not answered during this session, please put up your hand for me. Okay. Leon Venter. Leon? Okay, I'm gonna move on to Hagen Bin. Hagen?
Hagen, hierso gaan dit.
Goed, dankie en self.
Klaar nie, wie ek bel hierso vir ek is hierso by 'n sentrum in Bloemfontein. Het julle 'n skedule van al hierdie webinars wat nou gaan plaasvind of is dit op 'n relatiewe kort kennisgewing want ek het nou nie geweet van hierdie ene totdat 'n ouer vir my hierdie ding gestuur het en ek wil graag van julle dienste gebruik maak vir my studente.
Dit is nogal op kort kennisgewing, maar ons het gister aan al ons kliënte 'n skedule uitgestuur, 'n tydrooster waarop ons aangedui het wat word op watter dae aangebied. Sê my, is jy 'n sentrum wat geregistreer is by Impak?
Yes, ek is.
Okay. Ek neem aan dat jy die e-pos moes ontvang. Dit was redelik laat gestuur gister. Gaan kyk net daarna. Indien jy dit nie ontvang het nie, stuur net asseblief 'n e-pos na info@impak.co.za.
Ja, ek het nou net vir ons tutor support dame Marlies gestuur. Sy moet net vir my daai ding weer stuur.
Dis reg. Sy sal vir jou dan al die inligting deurstuur.
Ja. Okay, is reg so, baie dankie.
Goed, plesier, lekker dag verder. Bye bye. Diego, do you have another question?
National Organization for the Governing Board is in Waving.
Okay. JC Engelbrecht.
Morning, ma'am. I just wanted to know in this exercises that we did, we referenced the hypotenuse as the radius. So I was wondering, just because I do add maths, so I just wondered, will we eventually be able to use the characteristics of a circle to determine trigonometry?
That will definitely come into play, especially in grade 12.
Oh, okay. Thank you very much, ma'am.
Pleasure. Have a lovely day. Bye. Right. Alaya Hussein, do you have another question? I see that your hand is up.
Yes, ma'am. Where can we find the timetable for all of the webinars that are going to be happening?
Are you registered at Impak?
Yes, ma'am.
Yes?
Yes.
Did you say yes? Okay. So an email was sent out late yesterday. Please go and have a look at your emails. If you did not receive it, please just send an email to info@impak.co.za.
Yes, ma'am. Thank you.
Okay, pleasure. Bye-bye. Junaid Rennie. Junaid, you are self-muted. There you go.
Okay. Morning, ma'am.
Good morning.
When you're labeling your opposite, will it be on the opposite side of where your right angle is, or is it depending where your cosine or tan stands?
Okay. So your hypotenuse side is the only one that is over or across opposite your 90-degree triangle. So your hypotenuse will always be that the longest line of all of them. So that will definitely never be the opposite side. The opposite side is always, I'm just going to use this triangle over here now. If you look at the screen, I'm going to use the spotlight. So if I look at my angle E, the side opposite to E is the opposite side of E, right? But if I use the reference of angle F, so let's call it angle F, the opposite side to F will be that side, that 48. The adjacent that stands over there is in reference with the E. Okay. Do you see that your hypotenuse is the only one that stays stable? It is the side that is always over or across my 90 degree.
Okay, thank you, ma'am.
It's a pleasure. Have a lovely day. Bye-bye. Tandeka. Tandeka, you are self-muted.
Hello, ma'am.
Hi.
Ma'am, I just wanted to ask, how many marks is this?
It will be 1 mark.
Oh, okay. Thank you.
Pleasure. Right, I don't see a lot of other hands. I'm going to take down everyone's hands. I think that we did answer a lot of questions in this session. I am going to still give you some time to just download your handouts. Make sure that you download that so that you have that as reference. Just want to put this down as well. Right, sorry, we have some attendees here that would like to speak up. So yes, I think that we did answer quite a lot of questions. You can still type it in the question box. We will probably give some feedback on them as well as we go along. And make sure that you download this presentation in the handout box below. If you are not registered with Impact, you're welcome to contact us at info@impact.co.za. Right. Thank you so much for joining me this morning. I hope that all of you have learned something and that I will see you in 2 weeks' time.